Chapter 3, problem number 50. A speed ramp at an airport is a moving conveyor belt on which you can either stand or walk. It is intended to get you from place to place more quickly. Suppose a speed ramp is 120 meters long. When you walk at a comfortable speed on the ground, you cover this distance in 86 seconds. When you walk on the speed ramp at this same comfortable speed, you cover this distance in 35 seconds. Determine the speed at which the speed ramp is moving relative to the ground. So we can figure out how fast you can walk, okay? And this would be relative, we'll say, to the floor, okay? So your speed, walking speed relative to the floor, would be equal to 120 meters divided by 86 seconds. I'm sorry, 86 seconds. Now, then they say that if you walk at this same speed on the speed ramp, you cover the same distance in 35 seconds. So that means that this would be the speed relative to the floor, and then what they're giving you now is the speed of the person relative, let's say, to the ground. Okay, so the floor we'll call the surface of the speed ramp. And then you have the ground, and that's upon which the speed ramp is mounted. So that's 120 meters divided by 35 seconds. Okay, so that's how fast you walk relative to the ground. And we'll assume that all the motion is to the right, so that's positive, this is positive. And the unknown is the velocity of the floor relative to the ground. Wow, that's tricky. Okay, so here's the person walking. All right, so the person has a velocity of p relative to f, which is the floor, which is the surface of the speed ramp. And then the floor is moving the surface of the speed ramp at an unknown speed relative to the ground. And the velocity of the person relative to the ground is known. All right, so if I add VPF to VFG, I get VPG. So solving for VFG, I get VPG minus VPF. VPG is 120 over 35, and VPF is 120 over 86. And I'm getting about 2 meters per second is the velocity of the speed ramp relative to the ground. And that's in the positive direction.